In this lesson, you're going to learn some basic ways of analyzing processes. And you're going to do this based on some process metrics, very basic metrics like flow time, like flow rate, and inventory. So that's what we're going to do in this lesson. Before we get started getting into the nitty-gritties of the metrics, let's remind ourselves of what a process is and what a process does. So at a very basic level, processes convert inputs into outputs, hopefully adding some value for customers. Where do we see processes? We see processes everywhere. They can be internal to the organization in the sense that you may be talking about sub-processes within the organization, taking inputs such as information from within the organization and converting it into paychecks that are being paid to employees. So here's an example of a completely internal process. You have information about employees of a company, and the outcome is the checks that are being sent to the employees. You could be talking about a process that's external, getting raw materials from suppliers and converting it into finished goods for customers. So the customers are external, and the raw materials are coming from external suppliers. So that's a different kind of process. Processes can also be core to the business, or they can be support processes. Car manufacturing company, the core process is taking raw materials, sub-assemblies, converting them into cars, and the support processes are maintenance of their facilities, for example. So processes are everywhere around us, and what you should remember is that any type of process can be analyzed using the basic metrics that you'll be looking at today. So keep that perspective in mind as you take a look at these metrics that we're going to talk about today. All right. So again, before we get into the nitty-gritties of the measurement, let's take a look at what are the different flow units for different types of processes. So flow unit means for a physical good, it's raw material that is being converted into finished goods, right? So that's the most basic flow unit that we think about when we think about a manufacturing process, raw materials being converted to finished goods. When you're thinking about orders being fulfilled, the flow unit is simply an order. It's an order that you as a customer send to a company. Let's say you're getting something online, you ordered it, and you received the product from the provider. That's your flow unit. It's the order that you placed, and it's whatever mix of products that you ordered got delivered at your doorstep. That's the flow unit that you'll be analyzing if you were to analyze that process of orders being fulfilled. A flow unit, when you're talking about a service, could be the customer that's being provided the service. So when you go to a restaurant, you are the flow unit that is being used for the process analysis. It's how many customers come in, how much time do they take in the process, and at what rate are they being served, and what rate they're leaving. So you become the flow unit when you're talking about customers going to a restaurant. Similarly, for a healthcare process, it's going to be individuals who are the flow units. When you think of cash-to-cash cycle, it's money that flows in when you get money from customers, flows out when you pay it to suppliers. So there, the flow unit is money, and some of the metrics that we'll look at today you can apply to the cash-to-cash cycle in terms of looking at the velocity at which the money was flowing through the system, through the process. You could have projects which are long-term, and you are converting them over a period of months, years. New product development, for example, the flow unit would be the concept that gets converted into a particular product. So you start with a concept based on market research, and when the product reaches the shelves of the store, that becomes the end of the process. So the flow unit there is that concept that is being converted into products for customers. And finally, the flow unit could be information. For example, if you are an insurance company that receives applications for insurance, the flow unit is the information that came from customers and got converted into policies or quotes that were sent back to customers. So the flow unit there is the information. So the three basic metrics that we'll be looking at are going to be flow time, flow rate, and inventory. And what we'll do in this lesson is look at some of the basic relationships between these three metrics. Right. So the first metric that we're looking at here is the flow time. Now, flow time is very commonly referred to as throughput time. A good way of thinking about flow time is the time that it takes for a unit to pass through the whole process. There may be multiple activities in the process, and if I could mark a single unit with a red dot and I start my stopwatch when that unit enters the process, and I stop my stopwatch when that unit ends the process, exits the process, that would be the flow time. That would be the throughput time. Now, a couple of things or a few things that you should remember when you're thinking about throughput time. What is the start of the process and what is the end of the process is going to be determined by whoever's doing the analysis. Why is that important? It's important because the timing is going to start and end from that point. So if you're thinking about placing an order with an online provider, you place the order and you receive the order at your doorstep. If that's the end of the process, then the flow time is going to be slightly longer from your perspective than it is going to be from the company's perspective, which is thinking about receiving the order and dispatching it to you. So they're not including the time that it took for it to be delivered by the post office to your doorstep. A couple of other things you want to keep in mind as you're analyzing processes in terms of flow time. Flow time is going to include activities that make up the process. So there may be multiple activities. Each one is going to take some time to get done. That is obviously going to get included in the total time, but there's also going to be waiting between different activities that will get included. So if you were to think about you going to a fast food restaurant, it only takes you a few minutes at the register, at the counter to pick up your food, and at the soda machine to get your drinks. However, you are going to typically have to wait for a little bit of time or too much time if you go during rush hour, and that's going to get included in the throughput time and the flow time. When you have parallel paths for something to get completed, so if there's information that is being collected from you to give you an insurance policy, for example, then, well, you are sending your application to the insurance provider, but there's also information that they need to collect from outside sources based on some of the risk that they might be covering. So there might be parallel paths which might be working towards getting that quote to you for that insurance company. In the case of parallel paths like this, the longest of those parallel paths is going to determine the flow time of the process. So, and that should be very intuitive because obviously it doesn't matter if one of the paths gets done quicker. If it has to wait for the other path, that's the one that's going to determine the flow time for it. Flow time is usually measured in units of days, minutes, depending on what the context is. If you're talking about houses being turned around in a neighborhood, obviously you're not going to be talking about it in minutes. It's going to be more in terms of weeks and months. So if you're talking about a process like that, it would make more sense for you to use units of time that are going to be larger. So that's going to be flow time. Now, what I'd like you to do is take this idea of flow time and think about it from the perspective of if you were able to shorten the flow time, to reduce the flow time, what impact would it have on the cost of the product or the service, the quality of the product or the service, and the delivery speed, the delivery reliability, and the flexibility? What would be the impacts on all these aspects if you could reduce the flow time of that particular product or service that's going through the process? So take a minute to think about that. Now, some of the things that you may have thought about in terms of how does reducing the flow time impact what the cost of the product is going to be and the quality of the product is going to be, are going to be very intuitive, are going to be very obvious, but some of these may not be. So let's take a look at a list of things that happen when you reduce the flow time. How does it impact these different aspects of products? So when you reduce the flow time, the amount of inventory that is in the process gets reduced, and that is going to reduce the costs, right? There is less that is in the process. So if a piece of raw material spends a long time in the process before it gets converted to finished goods, there's going to be more inventory in the process. It's going to spend a long time in the process, in which case the cost will be higher because you're investing in that inventory, and that's why the cost will be higher. If you're thinking from a customer perspective, if you are a customer going to a healthcare facility, the more time you spend in the process, the more expensive it is for you. So even there, reducing the flow time, reducing the time that you spend in the system is going to be beneficial for you from a cost perspective. When you're thinking about reducing the flow time, you can think about it from a quality perspective. Customer is going to receive the product quicker. They can give you feedback quicker. Now here you can think about internal processes as well as external processes. If the time that it takes for a car manufacturer from order to receiving the sub-assemblies from one of their vendors, from one of their suppliers, is shortened, the time to get that part is shortened, they can give quick feedback to that vendor and say, this sub-assembly had these issues, these sub-assemblies had these problems. If the time is longer, the time that it takes to get feedback on quality problems is going to be much longer. So it'll take longer for them to get resolved. When you're talking about lesser flow time, you're obviously talking about a less order lead time, which anybody would like, right? As customers, as providers, if we can reduce the lead time, that would be good. When you're talking about less lead time, less flow time, you're also talking about a process being more responsive to customer requirements, right? So if customers can receive their goods quickly, and you don't have to worry about the time that too long how long it's going to take for it to get to them, you can make the changes to the products based on customer requirements and turn around quicker. Finally, thinking about new product development, it should be obvious that faster new product development, hopefully it's being done correctly and accurately, faster new product development would be good. So faster flow time in general seems to have benefits for customers. Now let's take a look at some of the other metrics that we're focusing on here. So from flow time, we move to flow rate. Flow rate is also called throughput rate sometimes, although throughput rate signifies the rate of sales. Flow rate, the way you would define it is if you were standing at the end of a process, it's the rate at which units are coming off of that process. Units are being readied from that process. Units are exiting that process. So if I'm looking at a restaurant, a fast food store, if I'm standing at the exit door, I'm basically measuring how many customers per hour exited that process, and that would be the flow rate of that process. It's usually computed as an average. So when we talk about process metrics and we talk about making analysis of processes, we are usually using an average. What does that mean? If you say the flow rate for a restaurant is 20 customers per hour, on average, it means sometimes it's 10 customers per hour and sometimes it's 30 customers per hour. So it's an average of observations that are taken over multiple periods of time. So in some sense, taking more observations would be better, but regardless, whether you take 2 observations or more, you are working out an average, and that's what you're using in your calculation. So flow rate is typically an average. It's measured as a rate, so it's going to be units per unit time, customers per unit time, or pieces per unit time. It could be money per unit time if you're looking at cash flow as your flow unit. Now, there's a concept of cycle time, which is a little bit counterintuitive to think about from a definition perspective. But I think if you think about it from a perspective of how it actually works out, it becomes much easier. So the concept of cycle time, let's talk about the concept first, and then we'll talk about the calculation. The concept of cycle time is if I'm standing at the end of a process, if I'm standing at the exit door of a fast food restaurant, Cycle time is defined as the time between any two units, any two customers walking out that door. So it's the average time between any two customers walking out that door. So it's intuitively it's saying that it's taking the number of customers that are walking out the door in an hour, and it's saying, well, divide that by the number of minutes in an hour, and that gives me the average time between any two customers that have walked out in an hour. So let's say if I had 60 customers walk out in 1 hour, the time between any two customers is 1 minute, so that's going to be my cycle time. On average, they came out in a cycle time of 1 minute. Now, again, you have to remember the important aspect of this, that we're looking at averages. They might not exactly be coming out at the rate of 1 per minute if you're thinking of flow rate, and they might not be coming out in a cycle time of 1 minute with a gap of 1 minute, but on average, that's what's happening. Now, the next concept requires you to think about the idea of a bottleneck activity, right? What is a bottleneck? If you were to take a bottle of water, a bottle of wine, a bottleneck determines how much output you get from that bottle when you tilt it, right? So it's what constrains the outflow from that bottle. We encounter bottlenecks when you have many lanes on a freeway that are converging to fewer lanes. So that's a bottleneck, because now you're taking a large flow rate and you are converging it forcing it into a smaller flow rate. So that's a bottleneck. So when you're talking about multiple activities in a process, a bottleneck is defined as the activity that has the smallest capacity. A more precise way of thinking about a bottleneck activity based on flow rate is it is any activity that has less capacity than the demand that's placed upon it, right? So if you need 30 per hour, but the task can only do 20 per hour, that's the bottleneck task, right? That's 20 per hour that you can get from it, and that's going to constrain the level at which that whole process can work. So the bottleneck activity will determine the rate at which the whole process can work. Why is this concept important? Because it relates back to the idea of flow rate and cycle time of a process. The cycle time of a process is going to be the cycle time that is the largest from all the activities that make up the process. The flow rate of the process is going to be the smallest of the flow rates of all the activities that make up that particular process. So that's why it's important to keep this in mind moving forward. Let's take a look at the final metric that we're going to talk about here in terms of the 3 metrics. So we looked at flow time, we looked at flow rate, and the final metric that we want to talk about is inventory. Now, inventory, which is sometimes called WIP, WIP, work in process, the idea of inventory is any units that are in the system, that are within the boundaries of the system, which are defined by the analyst. So the boundaries that are defined by the analyst, and you measure how many units are in that system at any point in time. And again, it's an average. So you're going to take measurements of how many units are in the system at different points in time, and then you're going to take an average of them. And once again, the more observations you can take, the better representation you get. Nevertheless, you can take 2 observations and get an average based on that in terms of how many units are in the system. So that's the third aspect, the third metric that we're going to look at. Now, to get a sense of what these metrics look like when you're talking about a particular process, let's take a very simplistic example. So here is a process for making table lamps. We have 3 activities in this process. Activity 1 and activity 2 are running parallel to each other, and activity 1 is making one part of that lamp, right? The base of the lamp is coming from activity 1, and the top part, the top piece with the glass, is coming from activity 2. These both have to come together and be assembled in activity 3. And we have the times that it takes for each activity to be completed. And just to be more precise on this, we say that there is one person working at each of these activities, right? So each of these activities has either one person or one machine, whatever the case may be. But it's one resource that's working at each of these activities. And what we're being asked to do here is to think of the 3 metrics that we just talked about. So you can report the flow time for the whole complete desk lamp being readied. You can report the flow rate of the process. And then we can also talk about how much inventory there would be in this process. But let's focus on the first 2 aspects, which is the flow time and the flow rate first, which are the simple aspects of this particular process. So let's take a look at these numbers here. So you have activity 1, which is the bottleneck activity here. It's determining the rate at which product will flow out. It has the largest cycle time. So the cycle time of the process is going to be 9 minutes based on 9 being larger than 8 and 6. The flow time of the process is going to be based on this being the largest and activity 3 being the next one. So it's going to be flow time of 17 minutes based on 9 plus 8. Now, once you have the cycle time of the process based on the largest cycle time of the 3 activities, which was 9 minutes, the flow rate can be determined by reciprocal of the cycle time. So you have cycle time of activity 1 as being 9 minutes. The flow rate, or what is also called the throughput rate, is going to be 1/9 unit per minute, right? And if you want to convert this into units per hour, you multiply it by seconds. In this case, it's going to be 1/9 unit per minute. So from the simple example, you can see that when you have parallel processes, you will take the longest one to determine the flow rate for the whole process and also the flow time for the whole process. Now, when you take a look at this example, it was a very simplistic example. And when we did these calculations, you may or may not have felt uneasy about some of the things that we were looking at here. So this was an imbalanced process. It had activities that were taking different times. What about waiting between the activities? We calculated the flow time based on 9 plus 8 equals 17, and we said it's taking the longest of the 2 pads and adding it to the common task and getting 17 minutes. So we assumed there was no waiting between activities. Now, would this be realistic or not? It's a question that you should be thinking about. The other thing that we said was that things are moving through at the rate of the bottleneck. Now, you didn't think about this. You may not have thought about this, but it was implied in this process design that we saw. So let's go back to this and take a look at the process for a minute. If you were to take activity 2, which takes only 6 minutes to get something done, and you start introducing raw material into that activity based on the 6 minutes that it takes for activity 2, what's going to happen over a longer period of time? What will happen is activity 2 will get done in 6 minutes, and it'll have to wait 3 minutes for whatever comes from activity 1, and it is also 2 minutes less than what it takes activity 3 to get done. So if you keep introducing items into this process at the rate of 1 every 6 minutes, the inventory at this spot is going to keep on increasing all the way to infinity. Activity 1 is never going to be able to get stuff done quickly enough for it to match activity 2 or activity 3. So inventory is going to build up if you were to introduce material into the system at any other rate than 1 every 9 minutes. So in summary, what you're saying, or what you're implying as an assumption, is that the material that's being released into the system is being released at the rate of the slowest activity. What we're also assuming here is that there is demand that's enough for consumption of these lamps. That's kind of an assumption that you don't necessarily need to make for any of the calculations, but we're hoping that the demand is not the bottleneck. So if the demand was less than the flow rate that we had for this process, then the demand would be the bottleneck, and you would be producing at the rate of that bottleneck. And finally, what you also assumed is that this process is working at steady state. What does that mean? Well, if you think about the first unit that came off of this little process, the first unit would have come out in 17 minutes, right? And the second unit would have come out at the 26th minute. The second unit came out 9 minutes after the first minute. The third unit came out 9 minutes after the second unit. So if you were to measure the flow time of this process, you're measuring it as 9 plus 8 equals 17. But if you were to measure the flow rate of the process, you are implying that you're measuring it once the process has reached steady state, because the first unit did not come out until starting from time 0, taking 17 minutes. So you assume that it was in steady state when you started measuring the flow rate or the cycle time. So these are some of the things that you want to keep in mind, or these are the things that you want to keep in mind when you are analyzing processes.